morning students. In last video we have seen some basic concepts of matter. We have seen phase change. Now today we are in part 2 of this chapter, and the first concept for today is Brownian movement. Brownian movement is the zigzag motion of the particles in the surrounding. Brownian movement is the zigzag motions of the particles of matter in a surrounding. Now we can understand by the diagram. Suppose this is any part of the matter, a small tiny part of the matter, okay, and we'll see its movement like in zigzag manner. The direction we can see like this is known as the Brownian movement. In 1827, the Scottish botanist Brownian have seen the movement of the particles, the movement of the tiny particles of the matter in a zigzag manner. Therefore, this type of movement of particle is known as Brownian movement. Okay. Then the next concept is diffusion. The meaning of diffusion is diffusion means the mixing of the particles of matter to one another. The mixing of the particles of the matter to one another is known as the diffusion. For example, a fog particles mix with each other due to the collision of air particles. When air particles collide with the fog particles, it will mix with each other, and that concept is known as diffusion. For example, one gas is mixed with another gas by the diffusion. Since the particles have the Brownian movement, that means random, or we can say zigzag motion, each and every particles of matter having the zigzag motions, and when in the zigzag motions, when they collide with the surrounding air particles, then they will mix with each other, and this concept is known as the diffusion. As I said, two gases mix with each other is known as the diffusion. The best example of diffusion we can say when we are using perfumes, the spreading of the smell of perfume throughout the room is an example of diffusion. Clear? Now we have seen the various phase transfers of matter, that is solid to liquid, liquid to gas. But we should know that which are the substances or which are the factors plays an important role in the phase transfer of matter from solid to liquid and liquid to gas. The first factor which is responsible for the phase transfer is temperature. Now we know that as the temperature increases, the Brownian movement will increase. Why? As I said, as the temperature increases, the Brownian movement will increase. That means what? When the temperature increases, the intermolecular force of attraction between the particles decreases. That means the molecules or atoms of the particle can go little bit away from each other, and they will have a zigzag motions. Temperature plays very important role for the conversion of solid to liquid and liquid to gas. As the temperature increases, the kinetic energy of the particle increases. They move very fast in a random motion. Clear? Now we are going to see some basic concepts or some factors which are given in our chapter is boiling point. Boiling point is a temperature at which the liquid is converted into the vapors, or we can define it as when the liquid is converted into the vapor at a particular temperature, then that temperature is known as boiling point. Boiling point is a temperature at which liquid or water is converted into the steam, or we can say any liquid when converted into the vapors at that particular temperature. That particular temperature is known as the boiling point. Next is melting point. Melting point is a temperature at which solid substance gets converted into the liquid is known as the melting point. The temperature at which the solid substances get converted into the liquid is known as melting point. Clear? Then we will see one more concept, that is latent heat of fusion. Latent heat of fusion. Now this is very important concept. Okay, this is very important concept. We have to understand latent heat of fusion. That means what? Now we'll see or we'll understand this term, the latent heat of fusion, with one example. Okay. Now if the ice cube is start to melt in the surrounding, okay, if we put ice cubes in open surrounding, then ice cube will start to melt. But when we see the temperature of ice cube is suppose 0 degree Celsius, then the water which is converted from ice to liquid, that temperature of that water having the temperature also 0 degree Celsius. That means ice when gets converted into water at that particular instant, the temperature of ice cube and that water is already equal. But the question is, then where the heat goes, where that heat goes which the ice cube have absorbed from the surrounding. Okay, see, ice cube when converted into the liquid, when ice cube starts to melt, it will absorb some heat from the surrounding. But the question is, if the temperature of ice cube and water at that particular instant is equal, then the question is where the heat goes which ice cube have absorbed from the surrounding. So we'll understand the latent heat of fusion. The latent heat of fusion means to convert solid to liquid, to convert any solid into the liquid, whatever the heat is absorbed at that particular instant is known as latent heat of fusion. For example, any substance, for example this marker having the melting point 25 degrees Celsius, or we can say not 25 degrees Celsius, suppose this marker having the melting point 80 degrees Celsius. On 80 degrees Celsius this marker we can assume it converted into the liquid. Then at 80 degrees Celsius, whatever the heat is absorbed by this marker and it is converted into the liquid, so the heat is absorbed at 80 degrees Celsius on the temperature of 80 degrees Celsius is known as latent heat of fusion. Latent heat of fusion can be defined as during the conversion of solid to liquid at that particular melting point, whatever the heat is absorbed is known as latent heat of fusion, is known as latent heat of fusion. Then next is, after the temperature, one more factor which plays very important role in the phase transfer is known as pressure, Now, pressure do not have any effect on solid and liquid. By applying pressure on this solid, we cannot change the phase of this solid, or we cannot change the state of solid. For example, if I apply pressure on this duster, okay, its phase cannot be changed. Or if we'll apply pressure on the liquid, its phase cannot be changed, but pressure have very important role, or we can say pressure plays very important role on the gases. Okay, we'll understand the effect of pressure on the gases by one simple example. Okay, so attention. Now, by this diagram, we can understand when we apply the pressure on the gaseous molecule. Now, in container 1, first we have to understand the diagram. This is the piston. This is the closed container which is closed by the piston. Now, and these are the molecules of the gases. For example, if we are applying pressure on this piston, then gaseous molecule will come closer to each other due to the effect of pressure. Then, if we increase the amount of pressure, in second stage, if we increase the amount of pressure, gaseous molecule will come more closer to each other. Gaseous molecule will come more closer to each other, and if we goes on increasing the pressure, as we can see in the third stage, when the gaseous molecules comes very close to each other, we know that when the gaseous molecule comes closer to each other under the pressure and they are cooled. When the gaseous molecules are cooled under the pressure, gaseous molecules are converted into the liquid. That means what we have studied or what we have understood, that the gases have the effect of pressure. That means if we are applying the pressure, then the gaseous molecule can be converted into liquid, but the pressure do not play any role for the conversion of solid to liquid or liquid to gas. The pressure does not play any role. That means we can say that the pressure have no effect on the solid and liquid, but the pressure plays very important role in the stage of gases, in the state of gas. The next concept is evaporation. Next concept is evaporation. How we can define evaporation? Evaporation is the change of liquid into gas. The change of liquid into gas below its boiling point is known as evaporation. If any liquid gets converted into the vapor, below its boiling point, then that process is known as evaporation. For example, evaporation during the summer days, okay, during summer season, we are having sweat on our body. So that sweat, that water droplets in form of sweats which are on our body, okay, after some times it will be evaporated and we are feeling very cool. That means what? That droplets of water, or we can say the droplets of sweat, needs some heat from the surrounding to evaporate. Evaporation cannot be happen during or in the absence of heat. Evaporation requires some amount of heat but not very high. So in summer season, whatever the sweat droplets are on the body surface, that will absorb some heat from the surrounding and the water droplets will be evaporate from our body. Now when the water droplets are evaporated from our body, they will take some amount of heat from our body also. Therefore our body surface we can feel very cool. Okay, this is known as evaporation. Now which factors, okay, which are the factors which affect the evaporation? The first factor is temperature. Temperature, as the temperature increases, the rate of evaporation is increases. As the temperature increases, the rate of evaporation is increases. That is understood very clearly. Second, surface area. Okay, if the surface area is more, okay, more the surface area, more is the evaporation. Okay, if the surface area is more, then the rate of evaporation will be more. And the third factor is wind. If the wind flow, okay, the rate of flow of wind is very high, then the rate of evaporation will also be very high. Or we can say the temperature, surface area and wind is directly proportional. Okay, is directly proportional to the rate of evaporation. Temperature, surface area and wind, these three factors are directly proportional to the process of evaporation. And the fourth factor is humidity. Okay, but this fourth factor is little bit different from these three factors, because if there is humidity in our environment, then the evaporation process will get slower. Okay, more the humidity, lesser is the evaporation. Okay, see, if there is already humidity, or there are already during the humidity there are small water droplets in the atmosphere. Already there are water droplets in the atmosphere. Therefore, the rate of evaporation will be low in the presence of humidity. Clear? So these are the factors which affect the rate of evaporation. Next concept is condensation. Okay, condensation means what? The conversion of the vapors into the liquid is known as condensation. This process I have also explained in part 1, okay, but I am repeating it again. The condensation is the process in which the vapors gets converted into the liquid. When the vapors gets cool, they are converted into the liquid. See, vapors are the gaseous phase, and the molecules or particles of the gases are far away from each other. But when the vapors gets cool, the atoms, molecules or ions comes very close to each other and they are converted into the liquid, is known as condensation. Sublimation. Sublimation is the process in which solid gets converted directly into the gas. Sublimation. In condensation, gases to liquid. In sublimation, solid gets converted into the gases directly, okay, without going into the stage of liquid. Okay, solid gets converted directly into the gases. Examples of sublimation we can take: camphor, naphthalene balls, iodine, etc. Okay, if these substances like camphor, naphthalene balls, iodines, if these substances are heated, then by the absorption of heat energy, this substance will get directly converted into the gases. This substance will directly get converted into the gases, is known as the sublimation. Again I am repeating, sublimation is a process in which solid gets directly converted into the gases without going into the liquid state, is known as sublimation. Clear? Now we have seen the three stages, that is solid, liquid and gases. Besides these three stages, there are two more stages, that is Bose-Einstein condensate and next is plasma. Okay, I am repeating it again. We have seen three stages of matter, that is solid, liquid and gas. Okay, and the fourth state of matter is Bose-Einstein condensate, that is known as B stands for Bose-Einstein condensate. This is the fourth stage of matter, Bose-Einstein condensate. Okay. Now B Bose-Einstein condensate. Now what is the meaning of that stage? Okay. Now when the gases are cooled at very low temperature, when the gases are cooled at very low temperature, then this stage is obtained, which is known as Bose-Einstein condensate. And the fifth stage is known as plasma state. Plasma. Okay. So among all these five stages of matter, among these five states of matter, that is solid, liquid, gas, Bose-Einstein condensate and plasma, the plasma state is found in environment, or we can say the plasma state is in the highest concentration or in the highest amount. Okay, among all four states, the plasma states of matter is in the highest amount. And where this plasma state is obtained? It is obtained in the stars. Okay, it is found in the stars. Now, how this plasma state is found? When any substance or any atom loses the electrons, when any atom loses the electrons, then that electrons and remaining ion, when combines each other, then that state is known as plasma. Plasma state is having the illuminating effect. Plasma state having the illuminating effect. Okay, it is also observed, or it is also used. Plasma state is also used in the CFL bulbs, neon bulbs, etc. Okay, so now we have finished with this chapter. Thank you.